Hello everyone. In this video we will introduce polar coordinate system and we will show how to plot a point given by this coordinate. Well, so far we know that to describe a point in the plane we have what's called Cartesian coordinates system. Well, which every point is identified by a pair of numbers. One for the first one tells us what is the image of the point on the x-axis or the horizontal, what the other one shows us what is on the vertical one. Okay, well, you see that to describe a point we need kind of a rectangle. That's why you will see sometimes me saying that this is rectangular coordinate system. But now we wanted to introduce a new one called polar coordinate system. Here again, for each point we fix two numbers, first one and second one. And how do we do those numbers? First of all, instead of having x and y coordinate here, we have the pole, which usually we set it up to be at the origin if we are working with the Cartesian coordinates. And we have a polar axis, which is just positive x-axis in the plane. Then every point you can measure its distance from the pole. This is called radial coordinate, and that one is denoted by r, and that's the first one. The second number is the angle formed by the line connecting that point to the pole and the polar axis. So you remember the convention of this way going is positive, the other way counterclockwise positive, clockwise is negative angle, and so on. So instead of having like a network of squares and rectangles, this time when you're working with the polar coordinates, basically we are going to have something like this, that every point there can be identified by the radial coordinate. Here on each line you see there are marks 1, 2, 3, 4, and 5, and so on, and through the angle. So this is theta angle, so going from 0, pi over 6, and so on. Yeah. Let's do some example, plot some points by polar coordinate, fixed by polar coordinates. So the first one is radial, the second one is the angle. You first fix the angle here. So theta equal to 0, so we are working here, and r is 1. So on this ray, you fix the ray, you find 1, that is 1, so that is A. Theta is pi over 2, r is 2. This is, let me call this one B. So first fix the ray for theta equal pi over 2. Pi over 2 is the whole thing here. Yeah. And on this ray, you fix 2. This is 1, this is 2. That is B. Now I can fix it. Theta is 2 pi, r is 4, so 2 pi. So you go around once, come back. The 2 pi ray and 0 ray, these are the same thing. And coordinate 4, this is 1, 2, 3, 4. This is C. And pi, so this one pi, you go pi like that. This is the ray for pi. Then choose 5. 1, 2, 3, 4, 5. This is D, if I call this one. There are two conventions that we are following here. One is the convention 1. So the direction for angle measurement is counterclockwise. This is as before. Yes, we worked with this. We always go counterclockwise for theta. And when if it is negative, and for negative theta, we go clockwise. So that's the first convention that matches with what we had before. Now another convention is that sometimes radial can be negative. So if the radial coordinate is negative, so something like negative r and theta, well, if you look at the pole and polar axis, you fix first the ray for theta, yes? Now, if the radial coordinate is negative, instead of going and finding r here, you go backward. So you continue this on the other direction, and you go backward here, and you pick r there. So this is negative r and theta. I started with the ray for theta here, and then since r, the radial was negative, I went in the opposite direction. And in other words, this is always going to give us the same thing as r and theta. Theta plus pi. This is plus pi side, and then you do the positive one. Okay, let's see examples of this ones. For example, a negative 1, 0. So you always fix the ray for your angle, and then since it is negative 1, we have to go in the opposite direction and pick 1 there. So this is A. How about B? This is negative pi and 2. Negative pi, we go this way, and the ray for negative pi is this. Yes. And we'll pick 1 and 2 on this. So this is B. Pi over 2, so that is ray for pi over 2. And negative 4. If it was 4, I would go for that. But now, since it's negative, I have to go on opposite direction. This is C. Okay, let me clean a little bit here. And the last one, negative pi, which is this coordinate, this ray, and negative 5. If it was 5, I will go pick 5 from here now, but I have to go the opposite direction. This guy is D, if I write that D. Okay. So this is just basics of polar coordinates. In the next video, we will learn how to transfer a polar coordinate to a Cartesian and back.